All right, so today we're going to be talking about naming formulas, based on the formula we have here, finding the name of what this compound is, right? These are ionic because we have a metal and we have a non-metal, right? So we probably want to remember that.
So ionic is a metal and a non-metal.
Yep, a metal and a non-metal. These are ionic compounds. And they happen to be transition metals. So they're different from NaCl and CaO, like the compounds we talked about before. These ones are specifically transition metals. And we haven't talked about them for a long time because they're kind of weird, right?
Yeah, how are we going to find the charge form for the valence electrons?
Okay, that's what we definitely have to go over. The charges can change. We're talking about these guys that are in the middle right here, all of these transition metals, the center ones. And we know the charge of the non-metal, so that's going to help us find the charge of the metal. And there's a little bit of a trick to it. Fluorine has what charge?
I believe it has a -1 charge.
It does have a -1. Right?
And I know that because it has 7 valence electrons. So when it gets that one more, it becomes negative.
Right. And this right here, this number tells us that lead has a charge of +2. What we're doing is we're crisscrossing right here. This tells me that this lead has a charge of +2. So the fluorine has a charge of -1. It has to have a 2. There's really 2 of them to balance them out. Because remember, they have to be neutral.
Oh, I see. So it's kind of like a really easy algebra problem.
It does, yeah.
So it's like, since each fluorine is -1, and we have 2 of those fluorines, it's a -2. So to balance it out, to make 0, we have to have a +2 for the lead.
That's right. If we multiply this -2 or this -1 by a 2, then overall the charge on this side of the formula would be -2. And that would cancel out this +2. So the subscripts, in a way, can tell you what the charge of the cation of the metal is.
I see. Okay, yeah, it makes sense.
So let's name this compound. Fluorine we know, and because it is part of a compound, it's got to end in an "ide," right?
Okay.
These are binary.
So
There's 2 elements here.
Fluoride.
That would be fluoride. Remember that "ide," right? We talked about that when we were doing binary naming. So that's the second half of this. Now we're going to name the first half. Pb is lead, right? Now, because the charges of the Roman numerals can change, they can be different. We can have a lead with a charge of 1 and a lead with a charge of 3 and so on. We have to designate in the name which one we're talking about.
So fluorine will always be that -1, but the transition metals can have multiple different ones?
Right, the transition metals can change. So in the name, we're going to tell you what charge it is. It is going to be a charge of 2, and we designate that with a Roman numeral 2.
Ooh, Roman numerals. I have not done Roman numerals in a while.
Roman numerals, yeah, we don't really use them very much in like normal life, except for I guess like the Super Bowl. Probably seen Roman numerals used there. It's where you have I's representing 1s, and like X's representing 10s, and B's representing 5s, and all of that, right? Roman numerals are just like, we just have to use them sometimes. In this case, Roman numerals, Roman numerals, I was getting ahead of myself. Roman numerals tell you the charge.
So if I had an I, it'd be 1, 2 I's would be 2.
That's right.
3 I's would be 3. If I have an I and a V, that'd be 4.
Exactly.
And
Roman numerals tell you the charge of the cation. So this 2 is telling me that this lead has a charge of +2.
Gotcha. And we're always going to have the metal in the front, right?
Okay. That's right. The metal will always go in the front. The metal in this case is the cation, because it's the positively charged one. The non-metal fluorine is the anion, so it's going to be the negative one. Let's try this one, okay? This oxygen has a charge of -2, right? And this subscript told me that. The subscript told me that it has a charge of -2, but also I kind of knew it because of where it is on the periodic table. That's
cool.
its oxidation number, right? Now, because this one has a charge of -2 and this one has to cancel it out, this copper has a charge of +1, right? But since there's 2 of them, this half of the formula is going to have a charge of +2 to cancel out this -2. So that overall, it is neutral.
Oh, I see.
So if I was to write out this formula, this +1 tells me that I've got a Roman numeral of 1. So we've got oxide here from the anion. Oxygen becomes oxide. And this is Cu, copper. And that +2 tells me that I've got a charge of 1.
Oh, so it's
Roman numeral 1. Yes.
It's telling you the metal, and then it's telling you the specific charge of that metal.
Right.
In this instance. So that way, if we were to try to go from the name back to the formula, we would know exactly how to do it, how to put it together.
Exactly, yep.
Okay.
The Roman numerals are for the metal only.
Okay.
Okay.
So what about in this case? So I know oxygen has a charge of 2, but I don't see any 2's at the bottom.
You're right. So this one has a charge of -2. For this whole compound to be neutral, that means that the iron has to have a charge of +2 already.
Oh, I see. So it's sort of like you're going to simplify it at the end.
Yeah, basically.
Okay.
I don't have to add any other subscripts because their charges already kind of balance each other out, right?
Okay.
So for the subscripts, if I was to crisscross these, like if I was to crisscross them, I would have a subscript of 2 and a subscript of 2 there, but they're already, if I simplify, it's the same. It's just 1.
Since they're in a 1-to-1 ratio.
Right. So I can leave it as FeO, simplified.
Gotcha.
Right.
So we should check that non-metal charge then, just to be sure.
Right, right.
In most cases.
And so since this has a charge of +2, this is going to be iron 2 oxide. There we go.
Very cool.
It's pretty simple, right?
Yeah.
The Roman numerals tell me exactly what charge I am dealing with, and vice versa. So, what about Fe2? I have a feeling this is not going to be the same. I don't know, maybe.
Well, I think we would want to do the crisscross, and maybe bring that 2 up there and see what happens.
So the 2 goes up there, lead has a charge of +2. Oh, look, it is the same. And this was a 1, so we bring that up there. It's a charge of -1, but we knew that already based on where fluorine is on the periodic table, so that this half is a -2 because of the subscript, right?
So it's a -1 for fluorine, and we have 2 fluorines.
It's a -1 for fluorine, and we have 2 fluorines, so yeah, -2 overall for this side. And then this is a +2.
So would it be iron 2 fluoride?
It would.
All right. That's pretty easy.
It's pretty simple, right?
Pretty simple stuff.
Iron 2 fluoride. Okay, last one. We got a 1 subscript here, so we're going to bring that up. So chlorine has a charge of -1. And this 2 will go up there, giving me a charge of +2 for the copper. And making this overall charge of -2, right? For that side. So this is going to be, Cu is copper. And we have a 2, because we have a charge of 2, chloride.
All right, so that's pretty easy. So it looks like you just crisscross each
Just
time.
crisscross each time, and then use the Roman numeral to designate, right?
Mm-hmm.
So crisscrossing can also help tell you the charge, right?
Yeah, yeah. Crisscross applesauce.
There you go. Say cation.
All right.
Very good. Pretty simple, right? If you have any questions, definitely ask your teacher.
Yes, you're awesome teachers.